Good evening, friends. Welcome to Eastern Academy. We are into embedded system programming. On that, today's session is embedded systems, session 3. And this is fairly a different topic. People have a confusion between embedded system and VLSI. So before we get into the embedded system, let's have a small comparison today. And before we discuss about embedded system design and architecture, let us do a small comparison. We have I'd like to clarify some points where people use VLSI, where people use embedded system. Okay, so this has to be, you have to understand clearly about the different distinguish. What is this? That's most important for us. Even though we are in embedded system, we also should know about what is VLSI. Okay, so let us go to the board and start discussing about that. So first, to understand all the three, we need to understand about electronics. Electronics is very simple. I have an input, I have output. That's what electronics. And the input is electrical signal, and the output is electrical signal. That's all. This is not all about electronics. Don't confuse between diode, transistor. No, they are not electronics. They are components. So if somebody asks you what is difference of electronics, we have electrical signal and electrical signal output. We process here. For processing, we use the very important component of transistor. And the transistor can be used as either switch or regulator. When you use a switch, it's called digital. When you use a regulator, I call it as analog or variable resistor. It's not my definition. This is a definition given by the transistor inventors. So inside we make a lot of circuits. That's what we make. So electronics is all about circuits. We make circuits. And in the last class, we discussed about all those implementation, everything. Now let us come to the trick. Initial days, people have used the transistor itself, 3 legs, to connect and solder on the board. People use the transistors on the board to make the connections and make a circuit. But later, they made a very beautiful thing called they put the circuit inside the silicon. This is called silicon. So they put the circuit inside silicon, and this is called IC. You have pins out. So instead of making a circuit on the PCB on the board, I make the IC inside a silicon. So that technology is called IC, and there are SSI. How many transistors I put? LSI, MSI, LSI, and VLSI. All these things are within the silicon. Here, within the silicon, how many transistors we put inside? That's the meaning of that. You understand how many transistors we put inside the silicon? That's it. But initially they put only 10 transistors in 1950s. Then they put 100. Then they put 1,000 transistors. Then they put 10,000 transistors. Now you'll be surprising. How come on the same such a small IC, they put 10,000 transistors? What they do was, they actually use the lens and minimize that. They put it. Since they're becoming transistor becoming small and small, the current it carries will be very less. The, the current it carries will be very less. That's a problem. But then what happened? Beyond 10,000, they start calling it as a VLSI. There's nothing called afterwards. VLSI is the last. So we have a field called VLSI. That means that if I say VLSI, it means that IC design. IC design. Now, let us do one thing. Like IC design, I have IC now. I have IC. I have multiple ICs. Each IC does one. You would have studied in the college. One could be a 7400 AND gate, 7408. One could be 7432 OR gate, like so many ICs. You will connect the ICs like this. That we call it as a circuit. So we call the engineer who draw the circuit. This is a connector. From here it goes. Here is a connector. It goes. We call the engineer as a circuit designer. What is it? Circuit designer. So there is a software available. There is a software available. Using the software or called Eagle or CAD. Okay, there are so many CAD softwares available. We use the software and they draw the circuit diagram. This is called circuit diagram. Or schematic. We call that circuit diagram or schematic. So you would have tried these things in colleges. But what is the beauty is, after we draw the circuit, we make them on a copper board. So we exact dimension of the IC. And we put the connections like this. This is called layout. So they are called layout engineers. Or we call PCB engineer. So please understand, this is very important. So this whole field is generally called hardware. This whole field is called hardware. That means that every product when you buy today, whether it's a mobile phone or a computer or a remote control or your this one, what do you call VCR or your TV, you take any electronic product, every electronic product, there'll be a PCB. So that should be a PCB designer is required. And second thing is there will be a circuit designer. Okay, this guy is called hardware engineer or design engineer. So there are two things. One is called design, other one is called layout. In the hardware, there are two fields. The circuit diagram is called schematic. This was the only field existing in when I was coming out of college around 1970s and 80s. There was only field called hardware engineer. Understood? No other field. If you say electronics, that means circuit. That's all. That's why they teach you even in the colleges today. Electronic means circuit. Okay. And that is also called hardware because it is difficult to change. If you make the layout and if you solder the components, it's a big task for you to solder. Then came the field called IC. We have to thank to Jack Kilby. Jack Kilby. He is the one from Texas Instruments who invented the IC. So there was a field came for IC designer. Understood? In the IC designer, there are two types. Okay, I'll give you one thing here. Like IC designer, once again, there'll be somebody who will draw the circuit. And somebody will do the layout on the IC. This is called front end. This is called back end. Please understand there are two people there in the IC design. This field is called VLSI. So IC design field is called VLSI. There are two types of IC designers. Okay, understand. There are two types of IC design. One is called, I make a design. Design means circuit. I give it to the company. Let us take a simple example. You see here, I have a two AND gate and OR gate, a simple design. A, B. This is not gate A bar, B. This is A bar B. And this is B bar A. This is B bar. This is A B bar. This is A bar B plus B bar A. Take a very simple case. This is a XR, simple gate. This, you draw the design, you give it to the company. The company will make the IC and give it to you. Two inputs, one output. One for power supply, ground. And two inputs A, B and Y. You cannot change it. This IC is called AC, application specific IC. You cannot change the IC. The circuit is fixed inside. But later, what the companies did was, they are given IC. Internally, there are gates. Internally, gates will be there. Lot of gates. Not only two gates, n number of gates. These gates will not be connected. And there are pins. Power supply and ground. So please understand, they make IC and they are not connected internally. Now you draw the circuit on a software and on a PC, on a laptop. On a laptop or a PC, you draw the circuit diagram. Then the laptop will be connected to the chip. Okay, through a serial port or USB or whatever it is. Forget about the connection. Through wires you connect. And inside the IC, there is a unit called configure unit. Now what happened? You give the circuit, this guy will make the connections. Like whatever you wanted, it will do that. You can draw the circuit and do the thing. But it's okay. When you have a small design, it's fine. When you're trying to have hundreds of gates, it is very difficult to draw the circuit diagram too big. So what people did was very interesting thing. They have come out with a language. A language called, see that we normally think in the college, hardware means circuit. So they have come out with a language called hardware descriptive language. Let's take an example now. Now you know, for example, this is pin number 1, 2. So you have two inputs. So input AB. And this is Y is output. You can say Y is equal to A bar B plus B bar A. That, for example, you write. Enough. You are given an input, you are given an output, and you are given an equation. Now, this is a hardware descriptive language. We'll convert this and put it inside the chip. This is like a C language, what we discussed. There's a language called Verilog or VHDL. You understand? Then, like we have a compiler. They have called synthesis. So you write in a Verilog or VHDL that is getting converted to a connection diagram and give it here, get connected. So only difference here is, instead of manufacturer makes IC, you can make the connection at your house. This is called PLD, programmable logic device. Programmable logic device. This has three major portions: SPLD, CPLD, and FPGA. So what you are doing is, you are drawing a circuit diagram using a software. You are drawing a circuit diagram using a software. That software you're using a language called Verilog. That is what the VLSI engineers are doing. So all the three are same. Either you do this, see, either you draw the diagram, and make it on the board, and it works. Or write the diagram as a in A, B, Y. You say input AB, output Y, and Y is equal to A bar B plus B bar A, or A B bar, whatever it is. Now you write like this and put it inside the chip. And there are two types. One is called permanent. Other one is called programmable, or we call this as a configurable. Please understand, when you buy a chip from the market, the permanent chip means that you have to give it to the manufacturer. The manufacturer put the circuit, equivalent circuit here, and give it to you out. That is what the permanent one. So you cannot change once the manufacturer done it. So this IC, you can use it, but cannot change it. But whereas what is configurable IC is, you can change. For example, you change the equation. A into B and A bar, B bar, the connection will change. This at your home, you can keep this at your home or lab, and you keep on changing, and you can change the connection. But you don't need a technician to change the connection. The connections are done by the configurable unit here internally. So when you buy a IC, within the IC, there will be a component will be there, like a gates, but they will not be connected here. Unconnected gates. Understand? Unconnected gates. But this one is fully connected. This one is board is fully connected. So to understand the difference between what is a board designer or hardware, what is VLSI? In VLSI, there are two. One is called ASIC, One is called FPGA. But as I told you, that board is must. You cannot have any electronic product, that should be a board. Without board, you cannot do anything with the product. So for a product, there's a board. So that there's no question at all in this. And nowadays, we start putting everything into the ICs. That is also fine. Then what is the third one? What is the third one? Then we will compare. I'll explain all the three, then we'll compare all the three. So we should have, before we get into the embedded, we should have a thorough idea about, because after a week, we are going to start. This week and next week, I will talk about embedded. Then we are going to talk about embedded system programming. Exactly. From there only, we are going to start the making a small products on using embedded system electronic things. But that time we should not have a confusion. That's why I want to make sure that you understand this clearly. Wherever you have a doubt, ask me. You can stop and ask me wherever you have a doubt. Okay. So people say that I'm so happy with the VLSI, I'm happy with the board designer, I want to have an embedded engineer like that. What are the three fields? What you do that? That's a trick. So what the embedded system thing is much simpler. What they have done here is, it's quite simple. Understand 1 minute. Forget about all this thing. You don't know anything about electronics. You don't know anything about electronics. I put a table here. I put a table. For example, I have two switches input. I have two switches or three switches. And I have two bulbs. This is red bulb. This is green bulb. You understand now? Let me draw it slightly bigger way. Then you will understand. See, please understand. I have three inputs. Okay. I have three switches here. And I have two bulbs here. So there are three inputs, electrical input and electrical output. This is electronics. This is electronics. And this is all connected to 5 volt. And this is all connected to ground always through resistor. So when the switch is off, let us put the switch like this. When you have not pressed the switch, all the three positions will become 0 volt because I connected with the ground. So this guy is 0 volt, this is 0 volt. But the moment, sorry. So the moment I press the switch, then I give a 5 volt here. That time this guy become 5 volt. When the switch is off, this guy is 0 volt. Because no current, this guy is 0 volt. The moment I press the switch, this becomes 5 volt. So I'm changing the position of the switch. Now let us say I put a table like this. I put a table like this. There are three switches and two bulbs. I have switch A, B, and C. Now, all are off. Or C only can be on. And B only can be on. And B and C can be on. A only on. A and C. A and B. And ABC all are on. There are 8 combinations. You have 8 combinations. Am I right? You have 8 combinations now. Because you have 3 inputs. All the switches can be off or all the switches can be on, whatever it is, doesn't matter. Now, this output, red and green. This is red and this is green. Let us make it as the color itself here, red bulb, and this one is green bulb. One is green bulb, other one is red bulb. Okay. Now, when all are off, both are off. When C is on, green should be on, red should be off. When B is on, both are on, assuming. When all the three are on, you should blink. And this should be off. When A is on, A alone is on, then this should be off, this should blink. Am I right? Well, like this, we'll put everything. So this is what my requirement. This is what the requirement is called electronics. Understand? Now you have to make the circuit here. That is what in the college they have taught you. How to make a circuit inside the thing. Now we do a different way. You see here, I have a bulb here internally. I have a bulb. This is called C1, C2, C3. And I have two switches here. This switch is called X1 and X2. You understand now? This is connected to 5 volt. Am I right? Now, when you press on the C switch, let us say A, B, C, then C3 will be on, but that will not come to output. There is no connection between, this is input. This is output. So there is no connection between input and the output. You understand now? The trick here is, I have a person here. I have a person here. I told the person, I told him what I told him. There's a trick. I told him, hey, if C1 is off, that is what this A. Then B off means C2 is off. I'm writing in English. Please understand. I'm writing in a very simple English. If C1 is off, when C1 will become off? When A is off. And C3 is off. Do nothing. I told him do nothing. Then he will not do anything. I say if C1 is off, correct. And C2 is off, correct. And C3 is on. The moment you press the switch C, this will become on. He cannot see this switch because this is inside the box. Then I told him, if a C is on, you want green to be on, that is X2. I told him on X2. Okay, I told him on X2. So he is going to on the X2 now. I don't know whether you are understanding or not. Am I confusing or not? The thing is that I make an input here. Now this is not there actually. Let us assume. This is what my requirement. I have an electronics box. I have an electronics box which I want as an electronic engineer to design. What I want is, I have 3 switches input. And based on the 8 combinations, I want these outputs, which I've told you. That's it. Now, internally, we connect 3 bulbs. We call them as a C1, C2, C3. There's a human person, the human being. Then he connect 2 switches here. 5 volt. You understand? I connected to 5 volt. So now I'm giving the commands to him what he should do. If here C1 is off and C2 is on and C3 is off. See that? How difficult for you to write this statement from the table? Please let me know. I given a table. Now let us remove the whole thing. Let me put a thing here. Let us say that I have only two inputs. I have only two inputs, one output. A, B, and Y. 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 0. Am I right? I make it like this. I draw it slightly clear. A, B, Y. Okay. Let us make 4 combinations. 0, 0, 0, 0, 1, 1, 1, 0, 0, 1, 1, 1. Okay. Now I'm asking you to write it the same table in English. Am I right? How easy or difficult for you to write it on English? I'm going to write like this. If A is 0 and B is 0, Y is 0. Am I right? If A is 0 and B is 1, Y is 1. Am I right? I am writing whatever the table into English. I have done the same thing here. What I have done is, I have the table I have written into the English here. This I gave it to this operator. Then the operator will do that. Now you press any switch. A, let us call these 3 switches. A, B, and C. The problem is we have discussed a lot in the colleges. All the diodes, triodes, transistors, amplifiers, so many things. And we tend to believe that that is what electronics. So when we started seeing a very simple things, we are confused. That's a trick. Here, I can put any switch. This is what we call electronics. That is a box. That is this box. And 3 inputs and 2 outputs. This is called electronics. We can implement multiple ways. One of the way I'm telling now. First way we have seen was hardware. Then we have seen VLSI, how to do it on the chip. Now I am telling you that I have an operator and I give the instruction to the operator will do this. This is a third method. This method, if you don't understand now, let me know what you don't understand. Is this statement clear? 1, 2, 3 I've written. These 3 lines are clear or not? Because this is called the third field, embedded. So what I'm trying to tell you is that to be an embedded engineer, you need not require to know about all the gate design, nothing. As an embedded engineer, you have to know only one thing. Please understand, as an embedded engineer, from the requirement, this is called requirement. Somebody has given you the requirement. And you should know how to write this. Steps. These steps are called program. This operator I told you is called computing block. What is computing block? That is nothing but, the computing block is nothing but, this is called computing block. Which is nothing but one microprocessor, a ROM, and a RAM. A ROM is to store your program, this program, and microprocessor to execute your code, and RAM to store your variables. You have so many variables you will be using while programming. The variables are stored in RAM. So this is called computing block. So what happened was, they put inside the electronics, they put a computer. That field is called embedded. The moment I have a mic, you know that about microprocessor, it's a brain and it's a fool. It cannot think. It can do things. It knows how to do, but it doesn't know what to do. That's why it's called processor. Okay. It does processing. But you are the one, you are going to give this in English and put it on this, the ROM. This guy will take it from the ROM and execute. And he will store the variable in the RAM, because ROM is a read only. Read only, you cannot do that. So effectively what I'm trying to say is that to be an embedded engineer, if you say that I don't know circuits, I don't know analog, I don't know anything about electronics, you're welcome. You are welcome. You could be a wonderful person. But you should know that what is the input and output? How do I write it in English? That is what we call programming. That's why I always say, master C programming if you want to get into embedded. In all the embedded systems, you have a computing element inside the embedded. Today, 90% of the products uses embedded. Understand, in electronics, once electronics was 100% hardware. Only circuit design. But today, electronics is 3 fields: 10% hardware, 10% VLSI, and 80% embedded. I'll tell you why embedded became so famous. Why embedded? That means that anybody who do not know electronics, anybody who has not studied ECE or EEE or electronics in the college can be an embedded engineer, which none of people don't know. That's the reason still you are getting into the jobs. But nowadays, people are recruiting. Even a computer science, people are recruited in the electronics field. Please understand. So, don't get confused. Don't get confused about this field. Now, I'll explain to you that what we do here. This guy, this software here, with the help of microprocessor, will read the pins. That is like a scanf. In C, you have a scanf. Like that in electronics, we call input. In electronics, we call input. In C, you see scanf. In electronics, we call input. Same way, this microprocessor will give the out here, output, and output. You call printf in C. The same C, in a computer, you can use printf. In electronic, we use output. So, there's no difference between a C in computer and C in electronics. Both are same. So don't get confused between a terminology going on in the industry everywhere called embedded C. No, nothing called embedded C. If you use a C in electronics, that's called embedded. Why you have to use C programming? Because you are using a computer. Where? Inside the electronics. So we all know that electronics is built, computer is built using electronics. But we don't know that electronics is built using computer. So within electronics, we have a computer. Understand? We put all of them in a single chip called microcontroller. Or nowadays we call it as a SoC, system on chip. How come they are possible? It is because of the IC design technology. Now let us see a difference between VLSI, when I use VLSI and when I use embedded. We should understand the difference between these two. Okay. The problem with the embedded is this microprocessor read the instruction from the ROM and use the variables in the RAM and execute one by one. Okay. That means that this field programming, you know what is the meaning of programming? Understand the word called program. Program means sequential. Sequential, anything you do sequentially one by one, it is called program. That's why we call it the programming. The microprocessor will do one by one all the instructions. It cannot do anything parallelly. This microprocessor cannot do things parallelly. It can do only one by one. But whereas in the case of hardware, okay, if you use it on the AC core FPGA, there things will happen. There'll be so many blocks. Each can do parallelly. So because of that, because of its doing parallelly, let us take an example. If I ask you to add 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, how do you add? You will add 2 plus 3, 5. 5 plus 4, 9. 9 plus 5, 14. 14 plus 6, 20. 20 plus 7, 27. 27 plus 8, 28. You will do one by one because your brain has only one adder. Your brain has only one adder. Okay, that's the reason you will do it one by one. So that is slow. But whereas I implement them in the hardware such a way that 2 plus 3 will be added. 4 plus 5 will be added parallelly. 6 plus 7 will be added parallelly. Understand now? They will be added parallelly. Then the results will be added parallelly. So I'll get things faster. I do not have to add one by one. I can add things parallelly. So that is what the advantage of VLSI. VLSI is for fast. VLSI is for speed. But embedded is for slow. Because it has to do everything one by one serially. But to do the VLSI, okay, two problems. One problem is you need to have a more expertise. Second one is it takes time to develop. Three, it's costly. But embedded is very cheap. Anybody can do that. And it does not take any time. If you start today morning, by evening you will be able to have a project. The only problem is you have to be very open. The only problem you are not learning embedded is it's your mindset. It's your mindset. You think something great is embedded. Now I erase all these things. I'll explain to you embedded very clearly. You should know how to do the embedded. In embedded, you should put yourself inside the box. You should put yourself inside the box. And it's an input, there's output. How do you solve it? Write them in steps. That's it. This is called program. That's why I always write when you are, so this is nothing but your same C programming. So that's why I always request you to practice C programming. While C programming, you have to do one thing. You should write the steps in English. You should write the steps in English. Then convert it, whatever language you want, and compile it and give it to the microprocessor. That will work. If it does not work, you should come back here. What is my mistake here? That means that if you understand it correctly, the problem is not with embedded. You have a problem here. The problem is that you think embedded is a problem. No, it's not. The problem is not with embedded. The problem is your understanding of problem. How do I practice? This comes by practice. That's why we always start from very simple C problems. Same way, I will start with, once you have practiced simple C problem, then I'll say simple embedded system problem. Okay. You have to practice. This comes by this understanding of a problem comes only by practice. Whether you do 10 problems in a day or 20 problems in a day, that brings you the practice. So, no, what I'm trying to convey is that simple. The whole embedded literacy is very easy. How do you take it and go is very important. Don't get confused. There's nothing great about it in the embedded industry. So what generally we do here is, we have so many parameters outside. Could be heat, could be humidity, could be distance, could be light, could be phase, could be speech. Am I right? We convert them into electrical. We have a box. This is not electronics. We convert them into electrical. You may call them as a sensor. You may call them as a sensor or transducer, whatever it is. We convert them into electrical signal. Now this electrical signal goes into my electronics. There I write a software to do that. Then I give it back electrical. That I convert it to motor. Then I convert it to light. There'll be a converter. You understand? So there'll be a converter. This could go to heater, whatever it is, right? Or go to compressor. So you give a command here that will operate that. So this is generally called embedded electronics. This is actually, to do this embedded electronics, you need to be 100% good in C programming. That's all. You need not know anything about the heat sensor, everything. That somebody will do that. Some engineer will do the thing. Maybe electrical engineer or electronic engineer, whoever it is. You as a embedded person, they expect you to do this programming because that is quite tough. But today you get powerful microprocessors, so and high speed microprocessors, powerful and high speed. So you can start writing wonderful programs here. This change is the one we wanted. We are looking for what industry is looking for. These are all secondary. The first priority is, I give you input, I want this output. Are you ready? For example, if the heat of this guy is increased beyond the temperature, I want to on the AC. Okay. Same way, if the humidity is less, then I have to on the heater. If my distance is less, then I have to slow down the motor. I should not go and crash. You know that all the autonomous car, the cars are all like this. It's a light. Then if the light is less, then I have to on the light. let's say the room light, ambience is less or lumen is less, then I do that. Oh, I detect the face. I detect the face. Then I match here, write a software to match your face. Then I will on the motor to open the door. Am I right? I can do anything. Then I get a speech. I will get the speech here. I will remove all the noise and send it out. So everything's are happening here, the software. That's why you are most wanted person in the industry today. So to do this, I just explain about what is embedded. To do that, you need to be an excellent C programmer. Then why don't I use C++ or Python? Because when I compile them, already C is slow. The C++ and Python become much more slow. That makes a microprocessor to execute things slower. That means that the input to output time will be more if I use C++ or Python or Java. If I use C, the compilation is better. So I'll be able to, the time between input and output, that means that the heat is changing, how fast I on the AC, those time, the input to output time, that's called latency. That time matters. Whereas if you write a C programming, then that will be fast. Please understand, the embedded itself is slow. On embedded, C will be faster. That's all I'm trying to say. Compared to the ASIC, compared to VLSI, embedded is slow. So please, that's why, let's say I have a video. I want to process the video. Then you cannot do it in your PC. You cannot do it on your embedded. Because the video is very fast. If I need to have a separate hardware to process the video. Understand? Of course, nowadays systems are faster, but still it's not that fast. So understand the difference between three: board, VLSI, or embedded. To do the embedded, you do not have to work what is inside. You should know that what signals you are getting, what you should do, and you should be able to convert that into the few steps of program. That we will see it. First you master C programming. Maybe next week, after a week onwards, we are going to start the embedded system programming. There you will be understanding how we are doing it. Okay, when you start writing the code. So if you have any doubt now on all the three, VLSI or embedded, top level. Maybe one session at the end of this embedded, you want to understand. I'll have a small demo session on IC design. VLSI, how do I do the VLSI? We'll do it on FPGA board and show you that. In embedded, we are going to use the microcontrollers. Okay. In VLSI, we're going to use FPGAs. That we'll see later, not right now. I'm not confusing you. So please understand, embedded means software. That's all, nothing. These are all not part of embedded. Don't get confused. These are part of embedded system, that's all. But this all not actual. Here is this. That nowadays, this whole thing is put it in a microcontroller SoC system, single chip. So you buy a chip and start writing a program, you are wondered. Nothing is required. You don't require to know. That we are going to slowly learn that how we are going to do that. Practice, practice, practice. This comes only by practice. Don't take it very light. Do not take this very light. This is very easy. At the same time, very tough. You know why I say very easy? You do simple mathematical operation, nothing great. But why I say tough? You generally think, you have been told so many times, you can do it without practice anything. That's wrong. You have to have a constant practice. It's like an Olympic race or swimming or driving, like that. Since everything easy, whenever you see something easy, you don't practice that. That's a problem. Doesn't mean that you can do it. It's very, very easy. When I give a problem, you cannot write a program. That's why people are facing problem. Now, when I'm giving a problem, most people are facing is this. So embedded is nothing but a small computer inside the chip. Then you write a program. That program is there in ROM. That's what all about embedded. You do not have to worry about anything about embedded electronics at the outside. You can do wonders. Okay. There's nothing very great about embedded, but it does wonders. It may be easy. It does wonders. If you launch a Land Rover to Mars, you are controlling him here. All are embedded. If you do a small mistake, the $1 billion mission will be lost. We'll be losing about thousands and thousands of crores. It's a very small programs. You do wonders. This is what the industry wanted. So I hope I've made it clear that what is the difference between embedded and VLSI difference. Okay, VLSI is IC design, and then on the IC we write a program to do the things. Okay, there are two types of ICs. One is a configurable, one is of fixed IC, ASIC or FPGA. Understand? So with this in mind, we will go to the next session. There we will discuss about how do I do the embedded product design. What is the typical architecture of embedded? Then we will do the embedded system design. Okay, that we will do that. Okay, let's take a small break for about 5 minutes. Then we'll come back.